self-referencing joins. See, in this lecture we are going to be looking at referencing joins as a self-referencing joins. Self-referencing joins, once in thesis interview they asked me one question on self-referencing joins. Self-referencing joins, self-joins, or self-referencing joins, or self-joins are one of the important topic in joins. Let's see, in detail we will cover, right? Self-join, it is like self-referencing joins are useful for querying hierarchical data or comparing rows within the some same table. Okay, let's get started. Here we have a table of employees. Each employee is uniquely identified their respective employee, right, ID. Notice all that we have a column called manager ID, and this is actually the employee ID for like each employee's manager. So we have a self-referencing relationship between employee ID and manager ID, right? See, employee ID first name, manager ID job title. Employee ID, one employee ID Jude, first name Jude, employee ID is 1, and for James employee ID is 2, but for James manager ID is 1, right? So for James manager is Jude, and Amanda manager also Jude, and Bobby manager is James, and Henry manager is James, right? Like that. Here this is the table. Here how they will ask questions and all, like for instance James has a manager ID of 1, like that, right? See, that means that James is managed by employee ID 1, and we can see that employee ID 1 is Jude, right? Jude is the CEO. So this means that James reports directly to the CEO. Amanda also reports to Jude, and that we have Bob and Henry. We see directly. See here, the Bob and Henry, who both have manager ID have to, so they have report to James, right? Manager ID 2, the 2 is James, so they report to James. Who we can see is the sales manager, right? Let's join this table to itself so that we can see the job title and the name of each employee's manager, right? Here in this film, all of this query we have from employees as inner join employee C. Select E dot employee ID, E dot first name, E dot again E2 first name as manager name, right? E2 job title as manager title. Same question they asked in my interview. How to assign managers accordingly, like that, by using inner join first name as manager name and E2's job title as manager title. From employees, E inner join employee E2 on E manager ID is equal to manager ID is equal to E2 employee ID, right? By using inner join. See, so we are joining the employees table to itself, and we are aliasing the first instance of the table to the letter E, and the second instance of the employee table E2 aliased E2 to, then we are matching rows here. Each manager ID is equal to E dot manager ID and E2 dot manager ID employee ID, right? In effect, this means that the attributes we select from the second instance of the employees table uh, like are going to be the management details, right? Therefore, in the select list we have at least e to first name as the manager name and e to job title, right? See, as manager title, e to job title as manager title. This query gives us the following result. See, like this it will gives employee ID, first name James, job title sales manager, James sales manager, manager name Jude CEO. Like that we will get the result. Four results we will get, right? Swimming up so that we have manager ID next to the second table employee ID. See, to get join employee ID 2 with James in the table. However, notice that Jude the CEO is not included in the query result. See, Jude has null for manager ID. Say Jude null for manager ID. Therefore, there is no match to the second table employee ID since Jude has manager. Right? Since we are using an inner join, we only get matched rows, right? If we want to include Jude in the query result, then we can do so by using an outer join. For example, see left outer join. We are getting Jude written in the query result as we are using left outer join as null. See. This will preserve all rows from the left table, and this is the employees, right? Cross joins. Self join was completed. Let's see cross joins. We are going to look at cross joins. Let's get started into it. Here we tables. One is for stores and one for products. Notice that these two tables have no link between them. In other words, there is no column or set of columns we can join the two tables on. However, we can still do a cross join between the table. A cross join would join each row in the table to all the rows in the other table to cross join the stores table with the product table, right? See, we can write the following query in the from clause. We have from stores s cross join products p, stores s cross join products p. See, from stores s cross join products p. Simply in the select clause we are selecting all the columns from both the tables. This query gives the following result: total 6 results. It will give 6 results. In that way, every row in the product table, so the query result has all the combinations of rows between the two tables across join, right? It is called a Cartesian product as it performs a cross product between two tables. 2 3 just 6, total 6 rows. We have 2 rows in the store table and 3 rows in the products table. Overall 2 times 3 is 6, right? We get 6 rows when we do a cross join. Another way of writing a cross join query is to simplify, use a comma between the tables. For example, see, like this also we have in the from clause from stores s comma products p, and this will also do cross join. Without join, this will also cross join, right? Yes, comma stores s comma products p. It will also acts as a cross join. Cross join is very simple join. We don't need to specify on class. However, there are not many situations where we will need to use this type of join. Right, advanced join challenges, let's see later. Join challenges we will see in the next session. Stop here.